What's going on, you guys, and welcome back to the channel. In this video we're going to be building 5 Python beginner projects. So if you're just starting out in Python, you've taken a few tutorials online, or you've just learned the basics and you want to test what you've learned and also improve upon what you've been learning, then this is the video for you. So we're going to be doing 5 different projects. The first one is going to be a guess the number game. So the computer will be picking a number between 0 and 100, and we will have 5 chances to guess the right number. Now, as a quick demo, I can just show you now. So we have this. So we have a quick message that says, "Welcome to the random number guessing game. You will have to enter a guess between 0 and 100. So we can start off by saying something like 50. And it turns out in this case that 50 is correct. So let's give it another go. So in this case, let's go with 50 again. And then it hints to us whether or not to go lower or higher. In this case, lower. So we might try 25. Go higher, we might try 30. Go higher again, so let's try 40 this time. Go lower, let's go with 35. And in this case, the answer was 31 and we've run out of lives. Okay, so let's get building. So for the guess the number game, we're going to be covering 4 main areas within Python. The first one being user input. So we're going to look at how we can get a user to write something in our terminal, just like you saw in the demo. We're also going to be looking at how to import libraries. In our case, we'll be making use of the random library, and also while loops and if statements. So to begin with, let's cover the idea or the concept of importing libraries. Now that's very easy. In our case, we want to use the random library because we want the computer to pick a random number between 0 and 100. So to do that, we'll say import random, like so. Next, let's go ahead and create our print messages. So we want the computer to give the player a welcome message. So welcome to the random number guessing game. And then next, we want to just kind of establish the rules to the player so they know what the idea or the principle is for this game. So we'll say, you will have to guess a number between 0 and 100. And finally, we can just say, you will have 5 lives. Okay, so if we were to run this, let's go ahead and open the terminal. Now I'm using VS Code. You may be using something else like the Python idle if you're starting out from scratch, or PyCharm. But in order to run this, I'm going to say Python 3, and hopefully you guys can see my terminal. And now I type in guess the number, and we just get our message. So we get the welcome message and also the rules of the game. All right, so the next thing is we want to get the computer to choose a random number between 0 and 100. Right now, we're not making use of this random library, so let's do that. Say computer choice equals, and then random integer. And then we'll say 0 and 100. So pick a number between 0 and 100, including both 0 and 100. All right, so let's go ahead and actually just print that out and see what we get. So again, in the terminal, if I run guess the number again, we get 25. If I were to run it again, we get 83, we get 49, 88, and so on. So it's picking a random number, and the point is, when it comes to random numbers selection, a computer isn't truly random. I'm not going to go behind or over the maths for this, but if it's just a kind of trivia question, can a computer really pick a random number? The answer is always no. There is some kind of weird maths going on in the background that kind of gives the impression that a computer's picking a random number. All right, I digress. Okay, so let's get rid of this print statement. We don't need it anymore. Then let's establish the number of lives. So user lives equals, let's say 5. All right, now let's go ahead and define our game loop. So as long as the user has more than 0 lives, then the game will continue to play. Otherwise, or if the user guesses the right number, then the game is also over. So there are 2 cases. First case is if the user lives is 0, so if it goes down to 0, and also if the user guesses the right number. So we'll say this: while user lives does not equal 0. So whilst user lives does not equal 0, continue the game. All right. So the next part is we want the user to enter their guess. So we'll say guess equals, and then we will do our input, and we'll say enter your guess. All right. Now with the input, this will always retrieve a string. In our case, we want an integer. And the reason why we want an integer is because we'll be comparing whether or not the guess the user puts in is bigger than or greater than or less than or equal to the computer choice. So to turn this into an integer, all we have to do is wrap that with an int. So that will take whatever you put in and convert it to an integer. All right, so our first case is if the user guesses the right number. So for that, we'll say if guess equals, and then computer choice. Then we want to kind of give them a congratulations. So congratulations. And then we'll say the number that they put. So guess is correct. And then finally, we'll say break. Now this break, what this does is it will exit out of this loop. So whatever loop this break is inside, it will exit out of it. So in this case, if the guess, let's say the computer's picked 55 and you've entered 55, then if that guess is equal to 55, so now given that now guess equals the computer choice, so 55 equals 55, that's true, you'll get this print message. And then what this break will do is exit out of this while loop. So it'll say, okay, stop this loop, get me out of here. All right, so that's the case when the user selects the right number. So we'll just add a quick comment. If the user inputs the correct number. All right. Then we also want to have our hint messages. So if the user's guess is greater than what the computer's chosen, then we want to tell them go lower. Or if it's less than what the computer's chosen, then we want to tell the user to go higher. So here we can say else if guess is less than computer choice, then we want to say print go higher, like so. Then else if the guess is, we don't even need to write an else if again, we can just write an else, because in the final case is that the guess is less than the computer choice. So we can put else, in fact, let's just put else if, because it's a bit more explicit. Guess is greater than the computer choice. And we'll say print go lower. All right. Then finally, we want to deduct the user life. So we'll say user lives, and then we can say minus equals. So that decrements the user life, and we'll say 1. All right. So we've got it going pretty much. Like this is the crux of the game. So just to kind of go over it again, let's say that the computer has chosen 63 and our lives are 5. So while 5 does not equal 0, so that's true, then the computer will ask for your guess. If your guess does not equal 63 in this case, then it will say, let's say our guess is 30. Given that, because 30 is less than the computer choice, the computer will tell us to go higher. If our guess was, say, 70, then the computer will say go lower. However, let's say we actually guess 63, then we'll get this print, congratulations, 63 is correct, and then it will break out. However, for all the other cases, it will go either, the computer will either tell us that we have to go higher or we have to go lower. And then finally, user lives will go down by 1. So from 5 to 4, then 3, then 2, then 1. If it hits 0, then this while case is broken. So our final message, we can say something like this. So this is outside of our while loop. So if user lives equals 0, then we can say print, you have run out of lives. The answer was, and then we'll just say computer choice, just so the computer can tell the user once they've run out of lives what the correct answer was. All right, let's just add some additional comments here. We'll say if the user guess is less than the computer's choice, and here we can just say if the user guess is greater than the computer's choice. All right, so let's go ahead and give this a try. So I'm just going to expand this, zoom in a little bit, just clear this terminal. All right, so we'll say Python 3, guess the number. So welcome to the random number guessing game. You will have to guess a number between 0 and 100. You will have 5 lives. Enter your guess. Let's go with 30. Okay, go lower. 20. Go higher. So we know now that it's either between 20 and 30. Let's say 25. And turns out 25 is correct. You can give that another go. Say 45. Go lower. 32. Go higher. 40. Go higher. 43. Go lower. 42. 42 is correct. Now, we've set it to 5 lives. You can also make it harder. You can set it to like 1 if you want, or you can set it to 100. It doesn't really matter. You can pick whatever you want. But 5, we've set it as default. So, in fact, let's just have a look and see what it would be like if we had 1 life. So let me just expand this. Let's clear all this. So we have 1 go. In this case, this message is incorrect. You can, of course, print this message once the user lives have been defined, so you can use this as a variable in the print. So we'll say 50. You've run out of lives. The answer was 98. All right, nice. Okay, so that pretty much brings us to the end of our Guess the Number game. The next game that we will look at will be the rock, paper, scissors app. So we'll be creating a game where we create rock, paper, scissors. So for the next beginners project, we'll be creating a rock, paper, scissors game. Now, the way this will work is, let's just go ahead and run it. So this is just the end result. So we'll enter a choice, either rock, paper, or scissors. So we'll say rock in this case. And in this case, both the computer and I picked rock. So we then have a prompt that asks us if we want to play again, yes or no. Say yes. Let's say paper this time. Oh, we both picked paper. Let's go again. Paper. So this time the computers pick scissors. Scissors beats paper, you lose. We can play again. Let's say scissors. So computer picked paper, scissors beats paper, you win. So that's what we're going to be creating. And in order to exit out of it, you can always put N, and this will stop the game. Now, in this project, we will be making use of a lot of what we did in the Guess the Number game. However, the focus point of this project will be around dictionaries. Now, the first thing I want to do as we build this project, I want to kind of show you the more tedious way, or the quote-unquote incorrect way. It's not incorrect per se, like the computer still understands it. However, in the sense of it's not clean code, as one may put it. All right, so to begin with, first we need our random library again. And let's go ahead and create a list for the computer to pick either rock, paper, or scissors. So computer choices, and we'll say rock, paper, and scissors. All right, now we'll do our loop. So we'll just say while true. Okay, so the computer will first have to pick something from computer choices. So we'll say computer choice equals, and then random dot choice. So what choice will do is it takes in a list in this case, and it selects a random element from it. So we'll just say computer choices dot like that. All right, so this will either pick rock, paper, or scissors. Then we'll then get the user input. So we'll just say something like user choice equals, and we'll say input. As it's a string, we can leave it as this. So enter choice, and we'll just say rock, paper, scissors. And then we'll do dot lower, and what that will do is just a lowercase anything that they put in. So if it's rock in all capitals, it will just turn that into lower string, and that's all. All right, so first of all, if the user choice is not in the computer choices, then what we'll do is say continue. And I'll come back to what continue does in a second. Then we can say print, we'll say computer picked, and then we'll just put in the choice of the computer, so computer choice, like so. All right, then we'll create our if statement. So if the user choice equals, let's say rock, start with rock, then if the computer choice equals paper, we can say print the, say computer, or what is it? We'll say rock, oh sorry, it's paper beats rock, you lose. All right, then we'll have to say else if the computer choice equals scissors, then we'll say print rock beats scissors, you win. All right, so that covers rock. Then we need the case for paper. So I don't want to keep typing this out, and you can see where the problem already is. So every time we write in, so for each case, so for rock, we then have to deal with paper. So if the users, or if we picked rock, then we have to write what happens when the computer picks paper. We then print out paper beats rock, you lose. And then we have the same for scissors. We say rock beats scissors, you win. We then have to do the exact same thing for if the user choice was paper. And then we would have to do if computer choice is scissors or rock, then what happens? You win. So this is very tedious, and this is what I meant earlier when I said I want to show you the kind of long way to do this or the wrong way to do this, and then we'll go ahead and look at the right one. So this all is very tedious. And there's another case. Let's say, for example, you didn't just want rock, paper, or scissors. You wanted, I don't know, two others. So rock, paper, scissors, spider, and apple. Then you would have to keep on writing more cases for that. And that is just a lot of effort for something so simple. Now this is where we can make use of dictionaries. So let's go ahead and remove this if statement. And with the computer choices, instead of calling it computer choices, we'll call this victories. And this will be a dictionary. So for the first, the key will be the victory item. So in this case, rock. And what does rock beat? We know rock beats scissors. Like that. Okay, then we have paper. What does paper beat? We'll say paper beats rock. And then finally we have scissors, and we know scissors beats paper, like so. Okay, and then we can get rid of our computer choices. So if we go back now, we can see we get some issues. So the computer choice cannot just take a random choice from victories. So we need the keys, so the rock, paper, and scissors. To do that, we can say random choices dot keys. And this needs to be victories. So victories dot keys. However, the problem is that this will raise an issue because this isn't a subscriptable list. And what this is looking for is a subscriptable list. So we just need to convert this into a list like so. So that way now we can choose a random item from victories.keys. All right, and here we can do the exact same thing. We can say if the user choice is not in victories.keys, then continue. All right, so what does this continue do? All this continue does is restarts the loop. So it will read this, it then, because it says continue, it won't read anything underneath it. It will just go back to the start of the loop. So the computer will choose another item. The user will be prompted to enter a new option. All right, so let's continue with the application. So say if user underscore choice equals computer choice, then we'll say we'll do the exact same thing, and we'll say you both picked, and then user choice, and then we could actually just add there is no winner. All right. Okay, so that's if the user choice is the same as the computer choice. Next, we will have our else if case. So else if, actually let me bring that up a line. Else if the user choice equals, and then victories, and then we'll say computer choice. So in this case, if the user choice, so let's say the user writes in paper equals victories, and because the computer choice is, let's say the users picked paper, the computer has picked scissors, then if you were to access victories and then scissors, you would get paper. So that means the computer has won in this case, because the victory or the scissors is victorious over the paper. And here we'll just say print computer choice beats, and then user choice, and then we'll just add you lose. Okay, now if the computer choice equals, and then victories user choice, then we'll say print, we'll say user choice beats computer choice, and then you win. All right, so let's just go over this victories part again. So this victories dictionary, the key is the item, and the value is the item which the key beats. So in this case, rock beats scissors, paper beats rock, and scissors beats paper. So for our first else if, so if the user choice is, let's say, paper, and the computer choice is scissors, then the victories, and then if we reference or if we try to get the value from the key scissors, then we'll get paper. So therefore the user equals the victorious, or the object in which the computer choice is victorious, and we get our print message. And then the same vice versa, if the computer picks rock and the user has picked paper, so in our dictionary the users picked rock, and what did I say, paper or rock? I'm getting confused myself. But let's say the computer has picked scissors and we have picked rock. So the victory that we see is rock beats scissors, and as the user has picked scissors, we get the win. So it may take a couple moments for you to kind of stare at this and really soak in what's happening here. But the great thing is with this is we can extend it if we wanted more items. So if we wanted the rock to beat paper as well as scissors, we could turn this into a list and use it as like a reference in by lists. Okay, so then we want our play again. So we'll say play again equals input, and play again, we'll say y dash slash n. And then finally, we will just say if play again equals n. So if it equals no, then break. So that will end the entire loop. So just to kind of look at it from the top, we have our victories dictionary. So where the key beats the value. So rock beats scissors, paper beats rock, scissors beats paper. We then have our loop where the computer picks a random kind of item from our victories. So rock, paper, or scissors. The user is then prompted to enter their choice, and then we just check to see if what the user's entered is inside the valid list of choices. If it doesn't, then it comes to this continue keyword, and what this continue will do is ignore all of this and then start again from the top. Then we have our print, which just tells us what the computer's picked, and then we have the logic around who's won the game. And then finally, we have the play again. And if they want to play again, they can type in Y. If they enter no, or if they don't want to play again, that's a better way to put it, then they can type in N, and then the loop will finish. All right, so let's give this a go. Just zoom in a bit. Say Python 3, and then rock, paper, scissors. So let's enter rock. So computer picked paper, paper beats rock, you lose. Let's play again. So if I typed in something that's not valid, I'll be asked to enter something again. I'll say scissors. Computer picked rock, rock beats scissors, you lose. If I want to quit, I just type in N. All right, so that brings us to the end of our rock, paper, scissors project. In the next project, we'll be creating an application that reads from our file system, so reads from another file, and that will be a quiz game. So for this project, we're going to be creating a quiz application. Now, the cool thing about this project is that we're going to be getting our questions and answers from an external file, and this is going to be a JSON file which will contain all of them. So for example, with the key being what is the capital of France, and then the value being the answer. So in this case, Paris. Now, for those of you who don't know what JSON files are, that's not so much the point of this video. It's structured like this, so kind of like a dictionary in Python, where you have the key and then the value. I will be doing a video on JSON in the future. However, for the case of this video, we will just restrict to just using a JSON file like this. So with the key and value. All right, so let's go ahead and see what that'll look like. So we'll have Python 3, and then let's run the application. So welcome to the quiz game. What is the capital of France? We'll say Paris. Who is the first person on the moon? We'll say Neil Armstrong. How many hearts does an octopus have? 3. Again, I don't know all of these off by heart. I wrote this, so I kind of remember what I put in for the questions. What planet is the closest to the sun? So Mercury. And what country drinks the most coffee? Again, this is something I don't know, but we have a score at the end of it, so it keeps tally of how many you get right. So in this case, we got all 5 right. Now we can of course remove some of the questions and answers. So if I removed 3 of them, then we should only get back 3 questions. So if I run this again, so who is the first person on the moon? Neil Armstrong. what's the capital of France? Let's put something incorrect, so Madrid. And I'll say another incorrect one. But we only got asked 3 questions. We got 2 of them wrong. But the point is that as we add or remove questions and answers from our questions.json, the program will adapt to it. All right, so let's go ahead and code this up. So for this project, we'll mainly be looking at 2 concepts. So the first one being reading from a file, in this case a .json file, and also using the JSON library which comes with Python. So the first thing I've done is just gone ahead and created a quiz.py file, so nothing special there. But the next thing I'm going to do is create a questions.json file. Now this is where all our questions and answers are going to live. So make sure you title it questions or something that you'll remember, because the name of the file is important. Next, let's go ahead and add some questions in there. So we'll say something like, which country drinks the most coffee? We'll say in this case it was Finland. This is just something that I googled, it's not something I know by heart. Let's create another one. Which company invented the iPhone? We'll say Apple. What planet is closest to the sun? Mercury. Let's think of one more. How many sides does a pentagon have? All right, and here we'll just say 5. All right, so we've got 4 questions. So that's our questions file sorted out. Now inside our quiz.py file, let's go ahead and make 2 imports. So the first one is our JSON import. So this is what we'll use to read our questions.json file. And we also want the random library just to select a random question from the file. Okay, so the first thing is we want to, let's just print a message to our user. So we'll say, welcome to the quiz game. And I'm just going to add a \n, and that just creates a new line that just, yeah, like it creates more space below this print statement. All right, so we want to read our JSON file and we want to store that somewhere in our program. So the first thing is we need to do with and then open, and we need the title of our file. So in this case, it's questions.json, like so. And we want to say this as JSON file. Then we want to store that inside of a dictionary. So we can say questions equals and then JSON. So our JSON library, and then .load, which is a function that comes with it. And we just throw in our JSON file. So all that does is it opens up this file and stores it inside this variable JSON file. And then this JSON.load, given that this is a JSON file, it will take that JSON and basically just throw it into and turn it into a dictionary and give us back the questions.json file in a dictionary format. All right. Next, let's just set up the score. So we'll say the score equals 0. And we'll say whilst the length of questions does not equal 0. So for each question, as it will be selecting a random question from our questions dictionary, we want to also, once a question has been selected, we want to remove it from our dictionary. As it's stored in a dictionary, it won't affect the file at all because we've kind of separated that. We've loaded it into this questions dictionary, and then from there we'll make use of that rather than the file itself. And then once a question is asked, we'll then remove that from the questions dictionary. All right, so we'll say the question equals and then random.choice, so a bit like the last project where we use that for rock, paper, scissors, and then we want to convert this into a list. So questions dot keys, like so. So now we get a random question. Then we need to get the user to answer that question. Goes input, and we'll add a format string. So this is something, again, that's fairly new, that may be new to you. So this format string allows us to kind of chuck variables inside of strings. Super handy, use it all the time. So we'll add a new line as well, just to kind of print it underneath it. And we'll throw in questions. So you need the curly brackets here, and then the variable. So that format will put in a variable inside of the string. You just have to wrap it around curly brackets. And then we'll just give it a space afterwards, so it's not smashed up against the question. All right, then we'll say if answer equals, and then questions, and we'll use our answer as the key. Sorry, questions, and we'll use the question, because it's the key value is question answer. And then we will, if that's correct, so we'll add 1. So let's say the question is, what is the closest planet to the sun? We'll type in Mercury. The question will be used, which is, what is the closest planet to the sun? And that will come out as Mercury. And given that, because it's correct, score will be incremented by 1. Otherwise, we won't increment it. But either way, we want to then delete that question. So delete questions, and then question. And then the questions will continue. So the length of questions has now gone down by 1, and then it will ask that next question, delete it, and etc. until it gets to 0 questions left. Finally, we'll just print out, we'll use the format string again, a new line, your score is, and then say brackets, score. We'll add like an exclamation mark at the end. All right, so that's pretty much it. So let's go ahead and test this out. So open up the terminal, zoom in a bit, and let's do Python 3 and quiz. So how many sides does a pentagon have? Let's put in 3. Which company invented an iPhone? Let's say Microsoft. And what planet is closest to the sun? Let's say Mercury. What country drinks the most coffee? And we'll say Finland. So your score is 2. These 2 we got right, and then these 2 we got wrong. So let's go ahead and run that again, and you'll see that the first question I asked this time could be different from what we were asked before. So in this case, the first question is, what planet is closest to the sun? And if we type in Mercury, we keep getting more random ones. So this time the second question is, which company invented the iPhone? And you'll notice as well that the same question is not repeated because we delete it from the dictionary once the question has been answered. All right, so that brings us to the end of our quiz application. The next project that we're going to look at is creating a bit like our guess the number game, but in this time we're going to be doing guess the word game. So for this project, we're going to be creating a guess the word game, a bit like Hangman, if you remember from childhood. So the way in which this will look is, let's go ahead and run it. So we'll do Python 3 to run the demo. So we have 6 lives to guess a word. So we can start by going with A. Turns out A isn't in there. Maybe we could add like a hint saying that A is incorrect. But now our lives have decreased. Let's try the L. So we know L is in there. We still have 5 lives because we guessed the correct letter. Let's try P. P is not in there. We have 4 lives left. Let's go with E. Okay, E's in there. So what else? What else could we have in this? Let's try C. C's in there as well. Let's try H. So H is in there. It looks like the word is vehicle. And that's correct. And then in the end, you get congratulations, you got the correct word. So if you get it, so yeah, if we try and guess incorrectly, so Q, 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 and then you have run out of lives. So that's what it would look like if you run out of lives. Cool, so let's go ahead and code this up. So for our guess the word project, we'll mainly be making use of functions. So functions will be in heavy use for this application, and also flexing a bit more of the powers that comes with using strings. So let's first go ahead and import our random one, because we'll have a list of random words which the computer will pick. So import random, and let's go ahead and create a list of words. Let's add a few in there. We'll say apple, have breakfast, we'll have banana, and we'll have vehicle. All right, so we want our computer to pick a random word from that. So let's create a function that will deal with it. So we'll say define a new function, choose a word, and this will return a random.choice, and we'll throw in words. So this will just return a string, and that string will be a random string that has been selected from this list. All right. So the next thing is, if you remember from the demonstration that I showed you earlier, is that we have these dashes for the words, as the user is guessing the word. So when the user first sees it, they will see a word, but for each letter it will just be an underscore. Sorry, not a dash, but an underscore. All right, so let's create another one. We'll say this is create blank word, and we need this to return a string of underscores where the number of underscores is the same length of the word that the computer picks. So we'll throw in word, so we'll take in a word, and then from there it will return underscore. So there's a bit of a list comprehension for a letter in word. Now for beginners, a list comprehension may look a bit confusing, so instead I may just go with a different option. So let's just say blank word equals an empty list. This one will, for letter in word, we'll do blank word dot append, and then an underscore, and then finally we'll just return blank word. All right, cool. So this will return an underscore. So let's go ahead and just demonstrate that. So we'll say word equals choose word, and then we'll do print, and then create blank word, and that will throw in the word that the computer has picked. So let's go ahead and run this. Let me just expand this a bit. So Python 3 and then guess word. So in this case, I don't know what word it's picked. I think it's picked breakfast maybe. But for each letter in breakfast, it's gone ahead and replaced it with underscores. All right, so the next part is to display it in a more human readable way. Like this is a bit ugly, so displaying it as a list. So let's create a new function now, which will display the progress of a word. So we'll say, so for example, if the word is breakfast and you guess the word B, it will show the new version of this list in a more human readable format. So it will show the letter B. So display progress word, and we'll throw in the blank word as an argument. And all this will do is it will join this list and turn it into a string. So in order to do that, we'll just say like that. So there's a space between each letter, and then dot join. Now this is a method that you can call on a string, and we'll throw in blank word. All right, so let's go ahead and test that out. So this time we'll say create blank word, as that returns a list of underscores for that right now. We'll say blank equals, and then let's go ahead and call display progress word and throw in blank. And the reason why we're not wrapping this in a print statement is because this function itself returns has a print inside it. And so instead it looks like this, so in a much more cleaner and friendlier way to read. All right, So let's go ahead and start to create our game function. Now the core of our game will live inside this function. We'll call it game. First, we'll say print welcome to guess the word. All right, so we'll have this as our prompt. Let's add a new line to it. First, the computer will pick a word. So computer word equals, and then choose word. And we'll create our blank word as well. So blank word equals create blank word, and we'll throw in computer word. All right. Then we'll just create our lives. So we'll say 6 in this case, and let's just leave it at that for now. So the first thing we want to do is display it. So we want to kind of show like what it currently looks like. And we'll say display progress word. And we'll throw in blank word. All right, then we want to tell the user how many lives they have. So we'll say print, let's use a format. So F and then double quotes, add on a new line. You have, and then throw in lives, lives, left. Okay. Then we want the user to put in their input. So we'll say user underscore guess equals, we'll say input, and let's put that on a new line, guess a letter. So now the user is asked to enter a letter, and then we want to see if that letter exists inside our word. So right now we don't have anything like that. So let's go ahead and create a function that will deal with that for us. So above game, I'm going to create a new function, and I'm going to call this check underscore letter. This will take in a letter, so the letter that the user puts in, the blank word, so the current blank word. So if the user guesses the right letter, we want to show that in the blank word and update blank word. And then finally the word itself, so the word that the computer has chosen. So now we'll say for I in range, and will be the length of the word. And what this will do is go through each letter in the word, and if the word, so if word index I, so if the letter equals, or if the letter exists inside of word, we then want to reveal that word inside of blank word. So we'll say blank word where the same index equals letter. And then finally we can return blank word. All right, so now we can go ahead and use that. So we'll say check, or we'll say blank word now equals check letter. We'll pass in the user guess, the current blank word, and then the choice, the word that the computer has picked. Oops. Okay. So then we want to see whether or not that word actually is in there. So if the user underscore guess not in the blank word, so if the blank word hasn't been updated, then lives equals 1. So we're gonna deduct 1 life from it. And then here we can also add something like the letter, and then user guess is not in the word. Cool. Then we keep going. So we need to have this in a loop. So this isn't just the end of it, because this will just run once if we call this function. What we need to do is create our while loop around it. So we'll do this. We'll say, whilst the computer word does not equal the blank word, but the blank word of course is a list, so we need to convert it back into a string. So we'll say just double quotes and no space in between, because we need to bring together all the letters. dot join, and then blank word, like so. So if it doesn't equal that, and the lives that we have does not equal 0, then we want to keep playing the game. So keep continuing this round. Otherwise, let's say the blank word now equals computer word, then the loop will stop. And the other case is if the lives is now equal to 0, then the loop will stop as well. All right, so the final thing that we need to add in our game method is if lives, and this is outside of the while loop, so we want to print this message outside of it. If lives equals 0, then print you have run out of lives. Otherwise, we want to print congratulations, you got the correct word. Nice, perfect. All right, the last thing that we need to do is actually call this game function so that we actually can play the game. So we just have to do underneath all of this, just do game, like so. And then open up your terminal and let's go ahead and run this. So we'll say Python 3 guess word. All right, so let's go ahead and try it. Let's try A. So A is in there. Let's go with all the vowels. E is in there. I is not in there. Given that I know some of the words in that list, let's try some other ones. So S, B, and you can see how the lives are not being deducted every time we guess the correct word. R, K, F, and T. So we get breakfast, and then, yeah, congratulations, you got the correct word. All right, so that's pretty much it for the guess the word game. So that brings us to the end of our fourth project. The final one is going to be Tic-Tac-Toe. So for our final project, we'll be creating a Tic-Tac-Toe game. You may also know this game as noughts and crosses. Now, the way in which this game looks is if I run the demo. So we are told that we are X, so we're the cross in noughts and crosses. And then we're asked what row we want to enter our mark. So we'll say the 0th row, and then which column, we'll say the first column. So we get the top right corner, the top left corner, sorry. Then the computer makes its move, and the computer will always just place it somewhere random. So it doesn't do anything smart in the background. Okay, so for our next move, let's move it here. So where this highlight is here. So on the top row, but the middle column. So we'll go with 0 and 1. And then let's go with the top right. So we'll go with 0 and 2. And because we get the complete row, we get a congratulations, you have won. So that's what we'll be building. And just to keep in mind that compared to the other projects that we've been working on for this tutorial, this probably is the most complex. And again, if you're new to Python, this will probably take some time, or new to programming in general, this will take some time to digest. So you may have to kind of go over this part a few times to kind of really digest what we've been doing, as the complexity of this is a bit more compared to the last few projects. So as stated before, this project is the bigger project out of the last 4, and we'll be covering classes, 2D lists, and also just in general computational thinking. So we'll really be testing our kind of skills in computational and computational problem solving. Now, the first thing I want to highlight is how our board will look. So it will be a 2-dimensional list, meaning it will be a list that contains other lists. And the way it will look is like this. We'll have 3 lists inside of one list. And in order to reference or index a certain item inside of our list, we have to, so for example, if you want this element, you need to do something like this. You would do board 0 and 0, and that will get you the first element in the first element. If you want the second element in the first element, you do 0 and then 1, and then 0 and 2. And if you want the, let's say, the second element in the second row in the second list, you would do 1 and 1, so like that. That's going to be a bit mind-bending at first because 2D lists can be a bit confusing, but that's essentially how our board is going to be structured. Now we'll also be using classes in this to kind of mimic our board and also our game. So that's another thing that we'll cover in this project. All right, so let's go ahead and start by creating our board class. So we'll say class board, and we'll have our init. And all that we'll have is self.board, and we'll initialize that to an empty list. Next, we'll go ahead and create a method that creates our board. So we'll say create underscore board self, and then we'll say for I in range 3, as there will be 3 rows. And for each row, there will be 3 elements inside it, or 3 columns. So we'll say row equals an empty list. And then for j in range 3, we'll say row.append, and then a dash. All right, and then finally, we'll go ahead and say self.board inside this for loop, self.board.append, and we'll add the row. All right, so that's our board or our create board method. And then let's go ahead and create actually, let's go ahead and see what that looks like. So we'll say board equals board. Then we'll do board.create board. And then finally, let's just print out board. So board.board. And that .board is referring to this here. All right, so let's go ahead and open up our terminal. Let's go ahead and run it. So Python 3 and then tic-tac-toe. And that's what it looks like. We have a list containing 3 other lists, where each list contains 3 items, which when we begin with will be our dashes. But this, if you're playing the game, this makes no sense. How do we make sense of what our tic-tac-toe board will look like? So we can create another method inside our board, which will display it. So we'll say display board. First, we'll add like a print to begin with, just to give it some space. Then we'll say for row in self.board, and then we'll do for item in row, and we'll print the item, and then we'll add an end, so we'll add some space between each item in that, and then we'll do print, and then finally print again, just to give it some space. And this here will create the new row or display the next row. So now, instead of calling this, we'll do board.display board. We'll go ahead and run this, and we get this. So we get a nice 3x3 array or list of dashes. Okay, the next method that we can make use of is to see whether or not there is an item, there is an X or an O already on one of these positions. So we can do is say, let's do has item. So here we'll say self, and then we want the row as one argument, the column, and then that's it. And then we can say return self.board row and column if that does not equal dash. So if it does not equal dash, then it has an item and this will return true. If it does have a dash, then it will return false. So it does have an item. So it doesn't have an item. So, all right, let's go ahead now and create another one which will insert a mark on a certain position. So we'll say insert mark, and this will be quite similar to our has item. So we'll take a row and column. So we want to specify what position we want to put this mark in, and then it will just take in mark like that. And then we'll say return, or not return, we'll say self.board, and then row column equals mark. So when we say row column, we're meaning which row. Is it this one? Is it this one? Or is it this one? And then for column, we're saying, is it this one? Is it this one? Is it this one? All right, so let's go ahead and test it out. So let's say board dot insert mark, and we'll say that the row is, let's go with to look at our demonstration, our kind of example here. Let's add a mark in this position. So on the 0th row and on the first element inside it, or the second element inside it. So we'll say 0, 1, and we'll say the mark is X, like so. Then let's go ahead and display the board. So display board. Just clear the terminal. Let's go ahead and run this again. So now, first of course it displays the board from the method that we called earlier, and then it inserts the mark and then displays it, and we get our mark here. So you can add like a bunch of other marks, like a note somewhere and all that, and it will do just that. Now we're not adding any checkers. So for example, if you went out of bounds, so if you added it to the 4th element or the 10th element or whatever, you would get an error. But for the sake of this project, we're not gonna deal with errors so much, as they're kind of like, there are a lot of edge cases, and we kind of just want to focus on the main logic of this game. All right, so the next method that we need to add to our board is to see whether or not there is a complete row. So for example, if this row here is filled with X's, or if this row here is filled with X's or noughts, and this one here, so yeah, so that's the sort of method that we need. So for that, let's go ahead and say has complete row, and then self. And so we'll say that for row in self.board, if the length, and we'll turn this row into a set, and I'll explain what the logic behind this is in a second, equals 1, and dash is not in row, then return true. Else, or otherwise, just return false. All right, so what this set is doing is that a set is basically, if you haven't come across sets before, a set contains unique items. So for example, 1, 2, and 3 could be a set, but 1, 1, 2 couldn't be a set because 1 and 1 are duplicates. So in this case, what we're doing is we're taking our row. So let's say the row equals something like X, X, and X. So it's taking that and converting it into a set, which will look like this, X, because it doesn't contain any duplicates. If that equals 1, then that's how we know that the entire row has the same element. And we also don't want to include dashes. So if the row is, like for example, when we start the game, all the rows have dashes in it, which means that all the elements are the same. But in that case, it's not a complete game, or it's not a complete row because we haven't put anything in there. So that's what this set will do, and we'll use this quite often. So if the set of the row is 1, so if it contains the same element all throughout, then we return true. Otherwise, if it goes through all the rows and doesn't find anything like that, it will return false. Next, we want to do the same thing for columns. So this is a bit more complex. Now for this, we'll say has complete column. So here, we'll say a complete row equals set. and then the column index equals 0, and we'll have a while loop instead, just because it's a bit easier to control than having our for loop. And then the length of self.board, so basically 3. Alright, so whilst the column index is less than self.board, we can create a for loop which will go through each column. So we'll say for row in self.board, complete row, so our set, and then add the row, and we want the index of column index. So the first column index is 0, and it'll go through each row. So it'll go through this row first, and then this row, and then this row. And because the column index is 0, it will check this one, it will add that one to the set, it will add this one to the set, and then it will add this one to the set. And because sets contain unique items, we can then say if the length of complete row, let's put down a new line, if the length of complete row equals 1 and the dash not in complete row, then we can return true. And then after that, we can just call complete row dot clear, and that will clean the set. And then finally, we can increment the column index. So add 1 to it. So we'll move on to the next one. So after it's checked this one, it will then check the second elements. So it'll check this one, it will check this one, it will add this to a set, it will then add this to a set, and then it'll add this to a set. If all of them are the same, so if we turn it into a set and the set only includes the X or the naught and not the dash, then we have a complete column. And then finally, if it never returns true, then we can just say return false at the end. All right, so that's our has complete column. The final one, and in noughts and crosses you can have diagonals as well. We have to check that too. So first of all, we can check this diagonal where we go from here, and so 0, 0 to 1, 1, and then to 2, 2. That's a fairly easy one to do because we can just use a singular for loop for that. So we'll say something like has complete diagonal and self, and we'll say complete diagonal equals set, and then for I in range, length self dot board, and then complete diagonal dot add, and we'll put in self dot board I and I. So 0, 0, 1, 1, and 2, 2. And then we can say the same thing if the length of complete diagonal equals 1 and the dash not in complete diagonal, then we can return true. Otherwise, we want to check the next diagonal. So this one here, 0, 2, 1, 1, and 2, 0. So now this one's a bit trickier because the numbers aren't growing linearly, so the X or the row and column. But there is a pattern. So we see here that we have 0 and 2, and then we have 1 and 1. So in this case, this here, this 0 is increasing by 1, but this 2 is decreasing by 1. And then for the 2, 0, it's again increasing by 1 and then decreasing by 0. So the the X and Y coordinates basically, so the X is increasing by 1 and the Y is decreasing by 1. So we can use that pattern, or knowing that, we can use it to create our algorithm for checking the other diagonal. So for this one, we'll do something like column index equals, and we'll just set this to the length of the board, self.board, so 3, and we have to minus by 1 because we can't index by 3 because that's out of bounds. So set that to 2 in this case. And then we'll say for I in range, and then length, self.board. And we'll say complete diagonal dot add. And before we do that, we should actually clear the complete diagonal just to ensure that it's back to being an empty set. So just above our column index definition. So here we'll say complete diagonal dot add, and then we'll say self dot board, and then the index, and then the column index, and then we'll say column index minus equals 1. And then, so we have now our complete diagonal, and we'll just go over this in a second. But then we can add this if statement again. So let's just copy that and paste that underneath. And then finally, if nothing ever returns true, we can just return false in the end. All right, so for our other diagonal, where we're going from right to left, we have our, in fact, let me just copy this so we don't have to keep scrolling back and forth. Let me just copy it down here, just here. So here, let me just write the indents in. Oops. So here, what am I doing? This final one. All right. So to check the diagonals here, so we have 0 and 2. Our column index we've set to 2 basically, because the length of the board is 3 minus the 1 is 2. So we start off a column index here. So our I starts at 0, our column index starts at 2. So we're starting here first. And then we're adding that element to the set. And then column index decreases by 1, and our I increases by 1 because it just comes with the for loop. So we end up here. And then our column index decreases by 1 again. So we end up at 0, and our I ends up at 2. So we're back to being here. And so that's how we're kind of traversing this 2D graph diagonally from the top right to the bottom left. And yeah, so we now have our complete diagonal, and the final one is to kind of bind all these has completes into one last method that will determine whether or not we have a winner. So we'll say winner exists, and we can say here return self dot has complete row, or self dot has complete column, or self dot has complete diagonal. So if any of these are true, then the board can say that we have a winner. However, it doesn't specify who is the winner. That's the only gotcha here, and we'll kind of cover that in a second. Then let's create another function, another method that will just return a list of all the empty positions that are there, because we will need that for our computer to determine what move to make. So we'll say get empty positions, and then self, and then positions equals an empty list, and then we'll loop through our entire board. So for I in range, and then length self dot board, and then for J in range, length of self dot board, so 3 in both cases. And then if self dot board I, so the element I j equals dash, then we know it's an empty position, and we can just do positions dot append, and we can throw in I and j like so. Finally, we can just return positions. All right, so we have now our method that will return all the empty positions on our board. Okay, so now we have our board. Let's go ahead now and create our Tic-Tac-Toe class, and this class will represent the game as a whole. So we'll say class Tic-Tac-Toe, and let's create our init. And we'll say self.board equals none equals board, like so. And then we'll do self.board dot create board, so we'll initialize that board, and we'll say self.user underscore turn, so this will just keep track of whose turn it is. We'll say true because in this case the user will go first. All right, so now let's create a method that will get the user input. So we'll say get user input, and we'll say self, and we'll say while true, and then row equals input. And we want to cast that to an integer because our positions are numbers. So we'll say enter a row, 0, 1, or 2. Then we'll have our column, which again we'll say input enter a column, 0, 1, and 2. And then if not self.board dot has item, we'll say row and column. So if it doesn't have an item, then we'll just return our row and column. So we'll return 2 values here, so a tuple basically. And then finally print that position is taken. So we want to let the user know if they've put in a position that has already been taken, and then that way if they keep entering, let's say 0 and 0 and that's been taken, it will then ask them to put in another one. All right, so that handles our user input. The next one is we want create another one but for get AI input. So we'll say def, and we'll call it AI. It's not really AI, we'll just call it that because it sounds fancy. AI input self, and then free positions equals and self.board dot get empty positions. So now we have a list of all the valid positions, and then it'll just pick a random one from that. So random dot choice, and then free positions, and then it will just return choice. All right, and finally we need to import random. We never did that. So just on the top here, we'll say import random. Okay, so that's all good. All right, and then we want to create another one that will just switch the turn of a player. So we'll say switch turn, and that will just do self.user turn equals not self.user turn. So we'll just negate it. That's all it will do. All right, so the final method that we want to add is a play method, and this will just run the game itself. So we'll say play, and here we'll just add our first like welcome message, welcome to Tic-Tac-Toe, and then we'll say print you are X, and we'll say while true, if self.user turn, so if it is the player's turn or your turn, we'll get the user input, so row and column equals self.get user input. Then we'll insert that into our board, so self.board.insert mark, and we'll say row column and the mark we'll just see as an X. And then we'll check to see if a winner exists after that. So if self.board.winner exists, we'll say print, and then a new line, congratulations, you have won. And then end it with another new line. And then we'll break. So we'll leave this while loop. All right, so the next case is if it is not the user's turn. So given that it's a Boolean, we can just write an else, because that will then mean that it's the computer's turn. We'll say the computer is thinking. And then we'll get the row and column for the computer, self.get AI input, and then self.board.insert mark row column and naught. Then it will again check to see if self.board.winner exists. So in this case, we'll know that the computer is won because they made the last move. And when it comes to tic-tac-toe, the person who makes the last move, if there is a winner, it was the person who made the last move, which makes it easier in this case. So we can determine it based on that. So we'll say, you have lost, better luck next time. And then it'll end it with a new line, and we'll break. All right, so the final thing that we want to do, so after each kind of like cycle, if there is no winner, we just want to print out the state of the board. So we'll say self.board.displayBoard, and then self.switchTurn. So we want it so that the next person or the next player can make their move. And then finally, just as an end, once the game has concluded, we can do self.board dot display board. All right, so that pretty much concludes our game. We can remove all of this. And yeah, the last thing that we need to add actually is if it is a draw. So we know it's a draw if none of these, if the winner exists, is never true. So if you never win, or the player never wins, or the computer never wins. Now to do that, we can always just use the get empty positions. So here we can say get empty positions, and if the length of that is 0 and winner does not exist, then we can say that there is no winner, and we can finish the game. So we can say if self.board dot get empty positions equals 0, then we can say print no winner, or we'll just say it was a draw. All right, so, and then finally we can break. All right, so that's pretty much it now. We can go ahead and try it out. So let's open up this terminal, let's clear it. We'll say Python 3, tic-tac-toe. And why is it not running? Because we have to start the game. Yeah, so in order to play the game, we have to actually like call it inside the code. So we'll say tic-tac-toe equals tic-tac-toe, like that. And we'll say tic-tac-toe dot play. All right, so let's go ahead and run it this time. zoom in a bit. So enter a row, say 0 and 0. And now we've made our mark, the computer is thinking. You could also add a timer in here to kind of give it the effect that the computer is actually thinking, rather than getting like the immediate result. Then let's go for this column here. So we'll go with 1 and 0. And the computer went here. And finally, it looks like we have 1. Let's go with 2 and 0. And we get congratulations, you won. So it's checked the column. It's seen that these are all X's. Therefore, we have won. So you can play this a couple times. You can also like go ahead and change it. So mess around with it. So instead of having a 3x3 noughts and crosses board, you could have a 4x4 and see how that feels like, what that feels like to play. But that's essentially it for our tic-tac-toe game and also for our 5 beginner projects. One thing to note again and to state is that this tic-tac-toe game is definitely like a few steps above what we've been doing in the last few projects. So really take your time out to kind of soak in what we've done, kind of break apart what we've been doing. If there are areas that confuse you, of course, feel free to leave comments in the video if there are any questions that come up whilst building this. And yeah, that's really it. I hope you guys found this video very valuable. Stay healthy, stay safe, and I hope to see you in the next video.